Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 29, 2025, which was about 3 days ago. The standout claim is that the method turns language models into game decision makers that learn procedures through online reinforcement learning, reaching competitive performance with dramatically lower data and compute, while explaining each move. The paper is titled, Think in Games, Learning to Reason in Games via Reinforcement Learning with Large Language Models. And the implications for model training are quite significant. In short, the framework reformulates decision-making as language modeling and keeps natural language reasoning transparent throughout. So, this table spells out the prompt template that turns each game state into a language task, which matters because the model must reason and then select a macro action. The template asks for structured thinking in a think token block and a final action in an answer block. Action candidates list the 40 macro options, and the game state placeholder carries the serialized match context. This design makes rewards and evaluation straightforward. Alright, Figure 1 shows how the group relative policy optimization loop turns a game state into both a think trace and a chosen macro action, which then receives a simple binary reward via a rule-based verifier. Group relative policy optimization means the model samples several responses at once, then normalizes their advantages within the group. The policy gets nudged toward higher rewarded actions, while staying close to a frozen reference through KL divergence. So, Table 2 shows that training for game reasoning did not hurt general abilities, which matters because domain tuning can sometimes degrade broad skills. The table lists scores for math, memorization, subject exams, dialogue, logical reasoning, and instruction following. Most cells stay flat or tick up a bit, and the biggest gains appear on the BBH logical reasoning task. This suggests the reinforcement learning stage sharpened structured thinking, while preserving language understanding. So Figure 2 highlights that the language-guided reinforcement learning stage drives big gains in choosing the right macro action. The left panel lists accuracies, where adding group relative policy optimization lifts models dramatically, which shows that interaction-based updates translate knowledge into better decisions. The right radar plot breaks down mistakes across categories like situational misjudgment, meaning wrong high-level judgment under pressure, and those shrink after group relative policy optimization. Together, the panels argue for strong efficiency and clearer decision quality. So this table defines the 40 macro actions the model can choose, which anchors training, because rewards hinge on matching one of these options. The actions span categories like dragon control, tower pressure, defense, hero targeting, lane clearing, buff steals, jungle plays, and grouping, plus recall. Each row pairs a concise action name with a plain description, so the policy and evaluator share an unambiguous vocabulary. This standardized menu keeps reasoning high level and decisions comparable across matches. Wrapping up, 2 takeaways stand out. Language-guided reinforcement learning turns static knowledge into reliable game procedures with strong sample efficiency, and the method keeps reasoning transparent through think traces while preserving general skills. The broader implication is clear. Interactive, explainable policies can scale beyond games to other decision domains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.